The notes for Unit 3, Lesson 7 will cover combustion reactions. Combustion reactions are the fifth and final type of reaction that we'll cover in this unit. So combustion, when you hear combustion, you think of an explosion. So combustion is when you have a hydrocarbon. So a hydrocarbon is anything that has carbon and hydrogen in it, and it's burning an oxygen. So oxygen, remember, is O2. So fire needs oxygen to burn. So oxygen will always be one of the reactants. The nice thing about combustion reactions when you are trying to predict the products is that combustion reactions always form CO2 and H2O. So the products will always be the same. It's always carbon dioxide and water. The tricky part with combustion reactions can be the balancing. Sometimes these can be really tricky to balance. So in the example, C4H10 is your hydrocarbon. It's burning an oxygen. C4H10 is actually butane. It's the gas that they use in lighters. So butane burns an oxygen and always produces carbon dioxide and water. So like I said, the balancing can get a little tricky. So if you notice, the coefficients on some of these are a little higher than most coefficients than we are used to. So that can be the tricky part. All right, so here are a few examples. Take some time to pause the video, try them on your own, and then come back and see what mistakes you made and ask questions from there. All right, hopefully you've taken some time to pause the video and try these out on your own. So here are the answers. For all of these, we know that combustion reactions always form CO2 and H2O. So for every single one, we will always get CO2 and H2O. One tricky part to remember is with combustion reactions, sometimes people will get combustion reactions mixed up with single replacement because you have a single element and a compound. So you have to always look for that hydrocarbon. So one of the reactants will be hydrogen and carbon, and then the other will of course be oxygen. So that would be one thing to be aware of and pay attention to. Oops, use a different color. Okay, so here we go with balancing. I'm going to write down my atom inventory underneath. So on the reactant side, I have 1 carbon, 4 hydrogens, 2 oxygens. On the product side, I have 1 carbon, 2 hydrogens. Here's 2 oxygens, and here is 1 more. So we have a total of 3. All right, so carbon is balanced, hydrogen is not. So we have 4 hydrogens on the reactant side, so I need to put a 2 here. That would give me 4 hydrogens on the product side. Here I have 2 oxygens, and then here now I would have 2 more. So I would have a total of 4 oxygens. So now carbon is balanced, hydrogen is balanced, oxygen is not. So I have 4 oxygens on the product side, so I would need to put a 2 here to end up with 4 atoms of oxygen on the product side. So that would be your final balanced equation. All right, reaction 2. Again, if I make my atom inventory, 2 carbons on the reactant side, 6 hydrogens, 2 oxygens. On the product side, I have 1 carbon, 2 hydrogens, and 3 oxygens again. All right, so carbon is off right away for the first one. So if I put a 2 in front of the CO2, that would give me 2 carbons. Here I have 2 oxygens, and here I have 1 more. Or sorry, here in between CO2, I would have 4 oxygens plus 1 more would be 5. I'm going to erase these as I go so I can mark them up again. All right, so now carbon is good, hydrogen is not good. So I have 6 hydrogens on the reactant side, so I need to put a 3 here. So 3 times 2 would give me 6 hydrogens. Here's 3 oxygens plus 4 more would give me a total of 7. So don't forget, when you have oxygen in more than one place, then you have to add those oxygens together when they're on the product side. All right, so carbon is good, hydrogen is good, oxygen is not good. So here is the tricky part. We have 7 oxygens on the product side. Whatever number we put here, we're multiplying by 2. So that's going to end up giving us an even number. So with combustion reactions, this is kind of a common problem with combustion reactions. So one trick or hint is if you take the hydrocarbon and make it an even number, so basically if you double the amounts that you have, then the reaction will end up balancing itself. So if we put a 2 here, that would give us 4 carbons. Here we have 12 hydrogens. I'm going to erase this little arrow so I can keep changing. All right, so now carbon is off again. So I need to change the coefficient in front of CO2 to make it a 4. And actually, I'm going to change and balance hydrogen before I even change my oxygen numbers because I know hydrogen is going to be off as well. So I'm going to erase my coefficient for hydrogen. And on the reactant side, I have 12 hydrogens, so here I need a 6. So 6 times 2 is 12. And now I can go back and add in all my oxygens. So here I have 6 oxygens. Here I have 8 more, so I would have a total of 14. So to get 14 oxygens on the reactant side, I need to put a 7 in front of the oxygen. So like I said, if you run into that problem where you have an odd number of oxygens on the product side, then usually if you double your hydrocarbon out here and then fix the coefficients that you had, usually that works itself out. And then another suggestion and trick is oxygen is always in 2 separate products. So I would balance oxygen last because when you do hydrogen and carbon, the oxygen numbers are going to get thrown off and you're always going to be fixing them. So I would wait and balance oxygen at the very, very end. So I would do carbon first and then hydrogen and end with oxygen. So that's another little hint. All right, so here we go for the last one. I'm actually going to switch colors. Okay, carbon, hydrogen, oxygen. So on the reactant side, I have 3 carbons. I have 7 hydrogens here, but 1 more here is 8. So I would have 8 hydrogens. And then here is 1 oxygen, and here is 2 more, so that gives us 3. And then on the product side, I have 1 carbon, 2 hydrogens, and 3 oxygens. All right, so again, I would balance carbon first. So we have 3 carbons on the reactant side, so we need 3 carbons on the product side. And I'm actually going to wait to do oxygen at the very, very end. So carbon is good, hydrogen is not balanced. I have 8 hydrogens on the reactant side, so I need to put a 4 here. So 4 times 2 gives me 8. So then carbon is good, hydrogen is good. So now I can balance my oxygens. So I'm going to change my inventory for oxygen. So here I have 4 oxygens and here I have 6 more. So that gives me a total of 10 oxygens. Here, this is the tricky part, I have 1. So that 1 is going to make my oxygens odd. So now I have the same problem that I had in number 2. So I'm going to try the same trick. I'm going to put a 2 here and adjust everything so far. So I'm going to double my carbons. Hydrogen, remember I have, I'm going to erase this. I have 2 times 7, which is 14, plus 2 more here, which would be 16. All right, so now on the product side, I need to also fix my numbers. So I'm going to have to erase the coefficient that I have for carbon. So I have 6 carbons on the reactant side, so I need to put a 6 here. And again, I'm going to wait to do oxygen at the very end. I have 16 hydrogens on the reactant side, and so I need to change my coefficient over here. So I have a total of 16. So 8 times 2 is 16. All right, so now I can finally add up my oxygens. So here, 6 times 2 is 12, plus 8 more would give me 20. Here I have 2 oxygens. So whatever number I put in front of the O2 is going to equal out to 18 because I need 20 total. This is going to account for 2 of the oxygens. So if I put a 9 here, then I would have 18 oxygens for O2 and then 2 more to give me a total of 20. Whew. So like I said, these can be a little tricky to balance, but predicting the products part is easy. So let me know what questions you have. You guys are doing a great job.